Hi guys, I'm Daniel, and today I'm going to be showing you how to identify an acidic solution when dissolving certain compounds in water. Okay, so the first step to do here is obviously to write out each equation. Okay, so we're going to be adding each one of these elements or compounds with water to see what they produce. So let's first start off by adding lithium bromide to water. Okay. So LiBr plus H2O will yield lithium hydroxide and hydrobromic acid. And this is not our answer because if you can recall, lithium hydroxide and hydrobromic acid are both strong base both a strong base and a strong acid respectively. So it's really not going to be very acidic or any more basic. Okay, since they're both pretty much they're both pretty strong. All right. So let's write the next reaction, which is sodium fluoride. So sodium fluoride will react with water to produce sodium hydroxide and hydrofluoric acid. Okay, and this is not our answer either because if you can also recall, sodium hydroxide is a strong base while hydrofluoric acid is a weak acid. Okay, so this reaction right here is going to be strongly basic because sodium hydroxide is much stronger of a base than hydrofluoric acid is strong as an acid. Okay, so let's write our next reaction. So we have potassium hydroxide, and we're mixing it with H2O. Okay. So when mixing these two together, potassium hydroxide is a strong base. Okay, so it's really not going to bond to make anything with water. It's just going to dissociate into potassium and hydroxide, which is called ionization. Okay, so when mixing these together, you get K plus OH minus, hydroxide minus, plus the water itself. Okay. So this obviously is not going to be very acidic because there's nothing but ions inside it. There's no acids. Okay. So our next reaction, we have iron 3 chloride mixing with water. Okay. So iron 3 chloride plus H2O will yield iron oxide. So keep in mind that the oxidation number here of iron here is 3. Because there's 3 chlorines, okay? So we're carrying the 3 over here. So if you have a charge of 3 right here, there's going to be 3 oxygens, okay? So let's write 3 oxygens. Oh, that was an ugly 3. And also, let me erase that 3. It's very ugly. Okay. So we have 3 oxygens right here, and since oxidation number of oxygen is always 2, we write 2 right here. So it's iron 2 or Fe2O3, okay? And then that's going to be also making hydrochloric acid. Oh. So HCl. Now this can be our answer because hydrochloric acid is a very strong acid, and iron oxide is not in any base or any sort of acid either. So this is a very high possibility of being our answer. Now keep in mind this reaction is not balanced, but for the sake of the question, we're not trying to determine the amounts that we have present here, so I'm just going to not balance it. Okay, but just keep in mind that this reaction is not balanced. Okay, so don't use it when you actually have to find an amount of something. Okay, so the next reaction, let me switch colors to avoid confusion. So sodium cyanide is going to be mixing with water. Okay. Now this is going to react to form sodium hydroxide and hydrocyanic acid, HCN. That kind of looks like an E, but it's a C. Okay. Now this is not our answer because if you can recall, sodium hydroxide, like up here, is a very strong base, while hydrocyanic acid is a weak acid. Okay, so this sodium hydroxide is easily going to overpower this hydrocyanic acid to make the solution basic. Okay, so at this point it seems that this reaction right here is our best answer because hydrochloric acid is a strong acid, while iron 3 oxide is not a basic or acid or anything like that. Okay, so we're able to confirm here that D is the correct answer. Alright guys, I hope you understood everything, and I hope I taught everything well, and thanks for watching.